Hello again, everybody. We are now going to do case 2 of partial fraction decomposition. All right, so case 2, again, same setup. It's always the same setup of a rational expression of two polynomials. And this time, case 2 is when we have repeating linear factors. And repeating is not the greatest phrase, but just the idea of a linear factor raised to an exponent greater than 1. So we're just going to jump right into an example, and there's going to be one major difference. So look at this example. The denominator has already been factored into x minus 5, and the quantity of x plus 3 squared. That's what makes this method a second method, is when we have x plus 3 to the second power. Now, we already know that for the x minus 5, which is linear and not repeated, we're going to include a fraction for it, and we'll put a constant above it. But for x plus 3 squared, here's what you have to do. And if you look over here, it shows you that when you have a repeated factor, we actually need two fractions just for that one factor. And for each of them, we will put a constant. So we will make a fraction for the single of a factor, but we also need a second fraction for its repeated. And if it was to the third power, we would have a third fraction, fourth power, fourth fraction, etc. That's what you have to remember, is that sometimes I use the word build. Build the fractions when you have repeating factors. That's the only difference. So let me just jump to the setup of 2x plus 4 over x minus 5 times x plus 3 squared, and how I should set that up. Have a look at that. You see what I did? I set up a fraction for the x minus 5. It gets its own fraction, as it should. But then for x plus 3, I had to have a fraction for x plus 3 as a single and a separate fraction for x plus 3 as a squared. So that's the thing, that when you have repeating factors, you get more fractions. It's going to build into more and more fractions. That's the difference. The technique, though, is going to be the same. Hey, let's clear out our denominators. Again, I'm going to multiply the entire thing. Now, I have to make sure I eliminate all of my denominators. So that would be an x minus 5 and an x plus 3 squared. Now, be very careful as you distribute this. Think about what your equation would be. I'll build it with you. Now, the fraction all the way to the left, everything in the denominator would be canceled, so we would just have 2x plus 4. For this first fraction, we will have the a, and then the x minus 5 will be canceled. We'll be left with x plus 3 squared. Second fraction, we'll have our b. One of the x plus 3's will be canceled, so there will actually be an x minus 5 and an x plus 3. You can see this takes up a lot more space. And then finally, that third fraction will have our c. The x plus 3 squared will be canceled, and we'll have an x minus 5. Take a look at that and make sure you understand what I just did. The good news is our technique from case 1 is going to be the same. Let's substitute in values for x, and again, let's choose nice values that make things nice. So for the first one, I would substitute in x equals negative 3, because that will make my factor of x plus 3 0. Now let me carefully do that. If you don't mind me doing a little mental math, plugging in negative 3 on the left side would be negative 6 plus 4 is negative 2. Now, plugging in negative 3 into the factor next to the a is going to kill that term. So the a term is gone. Plugging in negative 3 into the b expression will make that go away, 0. And then finally, we will have c times negative 3 minus 5. So that'll be c times negative 8. And we have c equals 1/4. That's the first thing. They're not always going to be integers. Boo-hoo, it's a fraction. We can deal. All right, what's the next value that we should plug in? Probably x equals 5, because that will make x minus 5 go away. Again, substituting on the left, 2 times 5 plus 4 is 14. Now this time, the 5 plus 3, now order of operations, 5 plus 3, 8. 8 squared is 64a. But then the 5 is going to kill the x minus 5 of the b and the x minus 5 of the c. So we're done, and we would get that a equals, when I divide by 64, simplify, that's what, 7/30 seconds? Great, yay, we did it. We have A, we have C, but we don't have B. And we already used up the two nice x values that we could have plugged in. We plugged in -3, we plugged in +5. So now what do we have to do? The answer is plug in anything else you want for x. Personally, I prefer the number 0 or something like 1. You don't want to make it bigger than it needs to be. So let's see what happens if I plug in something that isn't quote unquote nice, like x equals 0. Well, x equals 0 on the left side, I would have 0 plus 4 is 4. A times, now 0 plus 3 is 3, squared is 9, so it's a times 9, or 9a. Careful with the middle term, a little more algebra here. 0 times negative, or 0 minus 5 is -5. 0 plus 3 is 3. That's going to be -15b. And then 0 minus 5 would be -5c. Well, boy, nothing went away, but that's okay because we already know A and C. So let's substitute in and solve for B. Let's do that now. Now I substituted in my A and my B, or A and my C. Obviously, I know it doesn't look that nice. In this case, feel free to use your calculator just for the fractions, although you should be able to handle this, and solve for B. So go ahead and solve for B now. And so you should have gotten B equals -7/32. Yes, these are not very attractive fractions, but that's okay. The numbers are what they are. Now the last bit will be, how do I write our answer? Well, think about it. We have A, we have B, and we have C. Even though they are fractions themselves, it's okay. You can put those fractions into the numerator of the original fractions. So as I erase a little bit, what's my final answer? And you would write your answer just like this, that we'd have 7/30 seconds over x minus 5 plus -7/30 seconds over x plus 3 plus 1/4 over x plus 3 squared. And that would be your answer. So it takes a little bit more work. The main difference is that you have to add one more fraction for any repeating factors. And then when you plug in, you might plug in two nice values, but then you just have to come up with your own third value to substitute in and solve for A, or whatever the missing variable is, A, B, or C. All right, so just like before, let's practice one more at the bottom. Now this one we have not factored for you, so we need to factor that first. Turns out, I don't know what we were thinking there. Turns out, I don't know what we were thinking. We would not expect. I would not expect you to factor that denominator yourself. As it turns out, and all I did was use my factor command in my calculator. This denominator is x plus 3 times x minus 1 squared. So you see we have the same pattern as the above example, a single linear and a repeated linear. So think about it. How many fractions should you have set up? Just like above, you should have 3 fractions. And plug in x values. You might have to plug in your own third value and see if you can find the constants, and you should have 3 of them, A, B, and C, for this problem. Take some time, pause the video, and check your answer in a little bit. If you're a little stuck, this should be your setup. After After you clear out the fractions, you should get to this line. The two easy substitutions should give you C is 1/2 and A is 5/8. So once again, how should we find B? Substitute anything you want. Once again, I will use 0, but you could do anything. And if you substitute correctly, you should get B equals 3/8. So your final answer is A is 5/8, B is 3/8, and C is 1/2 in this simplified, or rather decomposed, fraction expansion. That's case 2. Good luck with case 3.